Welcome back, folks. So what I got here is a number of oscillators at different levels that have all failed for one reason or another. We'll start here with the simplest one. This is just a basic, simple oscillator. I don't know how much you can be able to see of it, but yeah, I mean there's not much in there. There's a couple of transistors, some laser trimmed resistors, a couple of capacitors, and then there's this thing, and I don't know what that is. If somebody does know, I'd appreciate you leaving a comment on it. That I'd love to figure that out. But it's easy to see why this one failed, because here's the crystal itself, and it just fell off its stand, it was, I guess, mounted onto here and here. I didn't help the situation much, but when I cut it open, because I think I might have, maybe not. I think I might have cut in partially into the standoff there, but so that's it. That's a standard oscillator circuit in there, and the crystal there. Now here we have a TCXO. This is the one that I destroyed by shorting the output on it. Although, the amazing thing is, it doesn't look like there's any issue with the output, which is all over on this side here. The issue seems to be with this and the oscillator itself. The oscillator is just this little SMD can here, 24 megahertz. And this here appears to be either some sort of switch or a very low dropout regulator of some kind. I don't know exactly. I tried to look up the number on it, and I can't find anything like that. I can't even see the number properly. So I may have been searching with the wrong number, but there you go. And there's this little trim cap here, which trims the actual oscillation speed. Now, I don't know which of the devices here, but some of the devices here must be associated with the temperature control. I can't for the life of me find any. It looks like there's some optional items here, like in this space here and this space here, that are unpopulated. And this appears to be the controlling chip here. Again, I tried to look up the part number of that. I couldn't find that either, but I'm guessing that must be the controller. So basically you have input. It goes through this either a switch or voltage regulator into the oscillator. You have the oscillator control here, or discipline circuit here, which is supposed to have the compensation. Now this device here may actually have thermal compensation devices built into it. I don't know. And over here is a trimmer to trim the actual oscillation speed. And this is the output section over here. And so you can see it's a far more sophisticated device. I mean, at the center of is this, which is very similar to that crystal oscillator that we just looked at before. And they have all this additional circuitry here. So yeah, these are fairly interesting devices, quite a bit more complex than your standard oscillator, and hence generally quite a bit more money. This one wasn't too much. I think it was like 17 or 18 bucks Canadian, so it's not a heck of a lot of money. But anyway, I have more in order to replace the one I destroyed here. And yeah, that's if anybody knows anything about these and might be able to indicate what these chips are, that'd be great. I'd love to know that too. Okay, and then next one here is one of my $3 oscillators, and I've mentioned before. I'll include a card to one of the videos concerning these up here somewhere. But these are surplus items, or probably reclaimed items more than likely, from China. And these are CTI. This is a 5-volt square wave output oscillator. It's a full OCXO. So it's got its own oven inside it. And if you look here, look down the edge there, you can see the crystal, and you can see it's soldered to that metal plate. And then also there's this. It could be a transistor or a MOSFET of some kind, which I believe is the heat source. And all this here would be the controlling circuitry. So this would be a PID controller. And then you have modifiers for the output. I believe, if I'm not mistaken, Um, this is the voltage, that's ground, that's the output, and that's the control. So if you look at where all these go, and these devices here, I believe these to be coils. If somebody else, again, if you know more what they are, please let me know. But they look like they're big and chunky enough to be actual coils. I don't know why you need coils in a circuit like this, but there you go. And so let's have a, we can 1 second here, we can have a closer look at those other pieces of it. Just let me get a cutter here. I'm going to cut the legs on this thing and see if we can have a gander at the other side of the board. There might be more components on there, but I doubt it. I think it's just the crystal and the heat source, the controllable heat source. There we go. Yeah, that's about it. So I haven't had a look at this. Hold on 1 second. Let me have a look at this, and I'm going to look it up online as we're here, so I can have an idea of what this is. 1 second. So it turns out that this is a high current NPN epitaxial silicon transistor. So that's what that is. And this, of course, is just a 10 megahertz crystal. I'm going to try to see if I can look up the function of this device as well. Just 1 second. Now, unfortunately, I can't figure out what this one is. The markings on it are 501, and then it's got P130601 on it. Yeah, so I've looked that up, and Google says, sorry, we can't find anything. So there you go. So this is, again, quite a bit more sophisticated than a regular oscillator, and more sophisticated than the temperature compensated oscillator. So yeah, it's quite neat to see inside these things. Anyway, there you go, guys. We'll see you in the next one. Thanks for watching. Bye.